Alright, so this question here can be further complicated if we asked you to calculate the amount of grams of excess reagent. So our excess reagent in this question, if you'll remember from the previous video, was aluminum iodide. And I always like to calculate the molar mass of something that I'm going to calculate the mass of at the very beginning. So if we're going to calculate the molar mass of this, it's 1 aluminum plus 3 iodines. So the molar mass of this is 408 grams per mole. Now, before we can calculate the mass of this, we have to figure out how many moles were left over. And this is the tricky part for most students. So to calculate that, we have to find the total number of moles. So the number of moles left over equals the number of moles in total of aluminum iodide that you had, subtracting the number of moles that was used to make your precipitate. So the number of moles total, that's the easiest one to find because that's the first number of moles you calculated. So if you remember back to the other question, the total number of moles of aluminum iodide was 1.7 moles. And you take that number before you do the mole ratio. The number of moles used, that tends to be the hardest one to figure out. So let's go on to the next slide so that we can figure out how many moles that we use so we can finish this calculation. So we're trying to find the number of moles that were used, and to find that we have to remember how many moles of the precipitate we had. Now we can come at this question from two ways. We can figure it out from the number of moles of precipitate that were created, or we can figure it out from the number of moles of the reactant that was the limiting. I'm going to use the number of moles of the precipitate. And if you remember back to our last slide, or if you take a look at our last slide, the number of moles of that precipitate that was 0.3875 moles. And if you look back at the chemical equation, we are going to aluminum iodide, and we're coming from the precipitate, which was lead iodide. So the mole ratio is 2/3. So that equals the number of moles used, and that actually equals 0.258 moles. Well, now we have the number of moles used. So the number of moles left over equals the number of moles total, which, if you remember from our last slide, the number of moles total was 1.7. And now we know how much we used. So that equals 1.44 moles left over. Now, we asked the question, how many grams? So on the next slide, we're going to figure out the number of grams, and that should be simple for you by now. So the number of moles left over was 1.44 moles, and the molar mass of aluminum iodide is 408 grams per mole. So mass is going to equal the number of moles times the molar mass. So the mass is 588 grams per mole, or sorry, 588 grams. And if you look back to the original question, the lowest number of significant digits used in the original question was 3. So our answer is also in 3, which is 588 grams.